Hello students, welcome back to TutorHub, your e-classroom on YouTube. So today we'll be learning about special right triangles and we'll give you easy tips and shortcuts on how to master this topic. But before we proceed, please don't forget to subscribe to the channel, like this video, and leave a comment so that we'll know how we can improve in our next lessons. Again, don't forget to click subscribe, like, and share with your friends and leave a comment. Okay, so for today's lesson, our lesson would be about special right triangles. Okay, so what are these special right triangles? These are triangles which possess unique properties that make their side lengths and angles easy to determine without complex calculations. That means when you know the side lengths of each of the triangles and their angles have special relationships which make calculations for this much easier. So let's say we have the 45, 45, 90 triangle. The 45, 45, 90 triangle can be drawn through this. So it is a right triangle, right, on this side. Again, these two are what we call the legs of the triangle, right? And the longest side is your hypotenuse, right? Hypotenuse. Very good. Now, you notice that the 45-degree angle is opposite to one leg and the other 45-degree angle is opposite to the other leg. On the other hand, the 90-degree angle is opposite to the hypotenuse of the triangle. Okay? Now, what is the relationship of the length of the sides of the triangle with each of the angles opposite them? So, we say that each of the legs are congruent, meaning they have the same length, which we can represent as x, and the hypotenuse as a length of x squared root of 2. So again, the legs have a length of x, the hypotenuse has a length of x squared root of 2. So say for example, a leg has a length of 4, what would be the length of the hypotenuse? Very good. That would be 4 square root of 2. So we just substitute whatever the value of the leg to the x on for us to know the value of the length of the hypotenuse. So that would be x square root of 2, right? So in the case of the example, if it's 4, the length of the hypotenuse is 4 square root of 2. Did you get that? Very good. So let's say we have this example. So again, if the length of the leg is 4, what would be the length of the other leg? Okay, because it is a congruent triangle, right, with the same angles which is at 45 degrees opposite the two legs of the triangle, then we expect that the length of the sides of the legs of the triangle would be the same, right? So it would be 4. Then, what would be the length of the hypotenuse? Very good. That would be 4 square root of 2 because as we recall, the length of the hypotenuse is x square root of 2 and incidentally x is equal to 4. That's why we simply substitute 4 here for the value of x. Right? Did you get that, class? Was that clear? Okay, very good. Now let's have another example. What if the length of the side of the leg of a triangle, of a right triangle that has an angle of 45, 45, 90 is 2 square root of 2. Okay, the one leg has a length of 2 square root of 2. What do you think is the length of the other leg? Very good. It's also 2 square root of 2 because we expect that these two sides are congruent to each other. Next, what would be the length of the hypotenuse? You said, sir, that the length of the hypotenuse is x square root of 2. Therefore, if this is x, if 2 square root of 2 is x, then we substitute that here. So that would be 2 square root of 2 times square root of 2. Is that correct? Now, because square root of 2 multiplied to square root of 2 is 2. So you have 2 times 2. Therefore, the length of the hypotenuse should be 4. Okay? Were you able to get that? Very good. So that's how easy it is to determine the length of the sides of a 45, 45, 90 degree right triangle. Okay? Now, so we have the detailed calculations here, and the hypotenuse is equal to 4. Okay? Now, let's have another example. What if the length of the hypotenuse is given? It's 4, right? So how do we determine the length of the legs? So remember, the length of the hypotenuse is x square root of 2, right? And if the length of the hypotenuse is 4, then we can solve for x, right? So that would be, we divide both sides by square root of 2 so that we can isolate x on the other side of the equation. So what happens next? Removing square root of 2. Therefore, we have that. Then we rationalize the radical on the denominator. So we multiply the numerator with square root of 2 over square root of 2 to avoid having radicals on the denominator. Then simplifying that further, we have 4 square root of 2 over square root of 2 times 2, right? So we simply combine these numbers together to come up with this. So in the numerator, we have 4 and square root of 2. That's why we have 4 square root of 2 here. Then in the denominator, that's square root of 2 times square root of 2. That's why we have this in the denominator. Okay? Now, simplifying this further, we get 4 square root of 2. 2 times 2 is equal to 4. So that's square root of 4 in the denominator. Then, square root of 4 is actually equal to 2. So simplifying this further, we get, divide the numerator and denominator by 2. So you're left with 2 square root of 2 as your value of x. Okay? So that's how easy it is. Okay? Were you able to follow it, class? Very good. Okay? So it's really easy to determine the length of the sides of the triangle. Just remember the relationship between sides. Again, the length of the legs are x. The length of the hypotenuse is x square root of 2. Because we have the length of the hypotenuse, we equate that to the length of the hypotenuse, then we simply solve for the value of x, okay, which we showed through the solution here. Okay, very good. So therefore, the length of the sides of the the length of the legs of the right triangle here is 2 square root of 2. Okay. Now, let's go to a 30, 60, 90 right triangle. So if you have a 30, 60, 90 right triangle, one angle of the right triangle is 30 degrees. It's opposite to this side. The 60 degrees is opposite to this side, and the 90-degree angle is opposite to the hypotenuse. Okay? So, how would that come out? Okay, so the opposite side of the 30-degree angle would be x. That would be its length. And then, the opposite side of the 60-degree angle would be x square root of 3. And the length of the opposite side of the right angle or the hypotenuse is 2x. Okay? So 30x 60x square root of 3, and 90 degrees is 2x. Okay, so let's have an example. Again, remember, 30 degrees, the length of the opposite side is x, 60 degrees is x square root of 3, then for 90 degrees, that's 2x. Okay, now we have the value of the hypotenuse here, which is equivalent to 2x. So, knowing this, we can deduce or we can determine the value of x by dividing both sides by 2. Very good. So, what is 8 over 2? 4. Very good. So, that would be the value of x, which is opposite to the 30-degree angle, right? So, that's 4 over there. Then, how do we determine the value of the side opposite the 60-degree angle? Very good. So it's simply x square root of 3. Incidentally, the value of x based on our calculation is 4. Therefore, that's 4 square root of 3. Right? Do you agree? Yes. So the length of the side opposite the 60-degree angle is 4 square root of 3. Is that clear, class? All right. Please like this video if you're learning so far, and don't forget to subscribe. We'll have more examples moving forward. So this is our next example. So the value of the length of the side opposite the 30-degree angle is 3, and the opposite side of the 30-degree angle is x, I mean. For the 60-degree angle, it's x square root of 3. And for the 90-degree angle, that's 2x. Okay? So, what would be the value of the length of the side of the side opposite the 60-degree angle? So, that would be 3 square root of 3 because the value of x is 3. What would be the length of the side opposite the right angle or the hypotenuse? That's 2x. Your x is equal to 3. Then 2 times 3 would be 6. Let's check if our answers are correct. Very good. That's 3 square root of 3, and the length of the hypotenuse is 6. Were you all able to get the answer? Very good. So I want you to master this topic. And now let's solve more problems. Okay? What if the length of your side, of the side opposite the 60-degree angle is 5 square root of 3? Remember, for a 30-degree angle, the length of the opposite side is x. 60-degree angle is x squared of 3. And for the 90-degree angle, that's 2x. Okay? So, because the length of the side opposite the 60-degree angle is written as x squared of 3, therefore, we can say that the value of x would be 5. Okay? So therefore, the length of the side opposite the 30-degree angle would be, what's the value of x based on our deduction from the given value? Yes, that should be 5. Okay? If this would be x, we say that the length of the opposite side of the right angle or the length of the hypotenuse is 2x. What is 2 times 5? 2 times 5 is 10, right? So let's check if our answers are correct. Very good. So the length of the side opposite the 30-degree angle is 5, and the length of the hypotenuse is 10. Okay? So were you able to get the correct answer? Very good, students. Okay? Now let's have some exercise problems for this particular problem. Show your solution. Okay? For this particular problem. So let's take number 1. So you have 10 minutes to solve. Okay, let's skip that. And you try to pause the problem first before solving it. And I hope you're able to solve it by this time. Okay, So what would be the length of the special right triangle? Of the sides of the special right triangle. So this is a 30-degree, 30, 60, 90 triangle. So this would be 60 degrees. Therefore, this would be x square root of 3. This would be 2x, right? So opposite the 30-degree angle is x. Therefore, we say that the length of the side opposite the 60-degree angle is x squared of 3. That's 2 squared of 3 because x is equal to 2. So that's 2 squared of 3. And what do you think is the length of the side opposite the 60-degree angle? Very good. That's 4. Okay. Right. Did you all get the correct answer? Good. Very good. Good job. Now, let's go to the other question. We now have a 45, 45, 90 right triangle. Okay, the length of one leg is 3 square root of 2. What do you think is the length of the other leg? Because the angles are congruent, the legs should also be congruent. Therefore, it should also be 3 square root of 2. What about the length of the hypotenuse? So the length of the hypotenuse is x square root of 2. So our x is 3 square root of 2. Multiply that by square root of 2. So what is square root of 2 times square root of 2? Square root of 4, right? So that would be 3 square root of 4. What's square root of 4? Very good. That's 2. So what is now 3 times 2? Excellent, right? So the hypotenuse, the length of the hypotenuse is 6. Okay, so that's how we solve the length of the sides of the right triangle step by step. Is that clear? Okay, very good. Now let's go to numbers 3 and 4. We have the hypotenuse of a 30, 60, 90 right triangle. Okay, again, for a 30, 60, 90 right triangle, the opposite side of the 30-degree is x. For the 60-degree is x square root of 3. And the hypotenuse is 2x. Okay, if 2x equals 16, what would be the value of x? Okay, what is 16 divided by 2? If we divide this both sides by 2, very good. So x becomes 8, right? If x is 8 and we substitute it here in x, therefore that would be 8 square root of 3, right? So let's check our answers. This side is indeed 8, very good. And the hypotenuse is 8 square root of 3. Okay, very simple. Yes, that's how simple it is. Okay, now let's go to our final problem for today. Because we have a 45, 45 degree triangle, right triangle, the two legs are congruent. And if this side is given to be square root of 2, therefore the other side would also be square root of 2. But how do we solve the length of the hypotenuse? Remember, the length of the hypotenuse is x square root of 2. And if x is square root of 2, that's square root of 2 times square root of 2. What is square root of 2 times 2? What is square root of 2 times square root of 2? Very good, that's square root of 4. Then what is square root of 4? Very good, 2. So the length of the hypotenuse is 2. Okay, so that's how we solve the length of the sides of special right triangles. So in summary, the special right triangles may have a 30, 60, 90 degree angles or 45, 45, 90 angles. And these triangles would have a special pattern on how we get or calculate the length of the sides of these triangles. Okay, so thank you students for being with me today in our lesson. And please don't forget to subscribe to the channel, like the videos, and leave a comment so that we'll be able to know more about what you need to learn in school so that we can make videos of it and help you better with your learning. Thank you everyone. Happy learning and have a great day ahead.